Cool. What up? So I've had a long day, but let's see if we can crank out a question or two maybe, and to get some answers out. So let's start with two sums. These are going off of the New Year gift top 75 lists. I'll link it below. So cool. So for the first one, given an array of integers and a target, return the indexes of the two numbers that add up to the target. So pretty straightforward. Looking at the example, we have 2, 7, 11, 15, target's 9, so indexes will be 0 and 1, 2 and 7, and example 3, target 6, 3 and 3, so 0 and 1. And then the constraints, which a lot of people overlook, is 2 less than equal to the length. Let's see, all numbers, indexes, well, all values are going to be from -infinity to infinity basically, and the target's from -infinity to infinity. Cool. So there are a lot of ways we could do this. I'm gonna go ahead and copy this over to IntelliJ because I hate the IDE online. We will take in an array. So let me go ahead and do that. So input will be an array of integers, right? Cool. So there's a few ways we could do this. There's a brute force way, and then there's the one using a map. Let's do brute force first and then go from there, because it's technically easier to do, especially during an interview. When if you get stuck and you don't know how to approach it, it's a lot better most often to go ahead and just do what you know how to do, and then usually halfway through it'll kind of click like, oh wait, actually I can automate it this way. And not only that, like most of the time, if you're interviewing and do the problem using brute force, they want to see is that you can actually work through the problem, and then once you're done with it, they'll just ask you like, hey, you know, how can we optimize it? How can we do this? Like if you watch a bunch of the videos online, like how to work on a interview, that's most of the advice they tend to give you. And, you know, ask around. I've asked a lot of people who interviewed back when I was in college, and we were all interviewing for different companies. A lot of questions I'd ask other people, you know, because I want to be better prepared for my interview. Was, hey, how'd it go? Would they ask you? And most of the time was just, hey, I got stuck. I didn't know what to use. Small portion of them just froze and couldn't do anything. The other half actually worked through it, did the brute force, right? The most simple way to do it. And then most of the time, whoever was interviewing them would say, hey, that's nice, but what if we do it this way? Or like, what if I want to use this type of function, or let's say I want to use this type of data structure. But cool, let's go with that one first. So we have an array, right? So let's do 2, 3, 4. And what we want to do is we want to go ahead and loop through it. We want to try every single combination because we know for sure that an answer will exist because that's stated inside the actual instructions. Given an array of integers, nums, and ensure target return, and we could assume that each input will have one solution, right? So we have it set up so we're returning an empty array at the end. We'll never get there. It was just when I was compiling it, we have issues, and it was just kind of annoying seeing a little red sign, right? So we remove this. It's kind of annoying. That's fine. We're not gonna need this later, but for now it's fine. So first, what we should always do is map it out. You know, use pseudocode, however you want to do it, to go ahead and write out what you actually want to do. Because if you just go ahead and start the code, you don't actually know what you're doing, right? You're thinking through it. You might be writing half the code and then realize, hey, I messed up, or this is the wrong way, different approach. Usually a good idea to just go through it. Not only for questions like these, but for actual assignments or a project you're working on. It's always best to actually have an idea of what you're doing. You know, that seems to be the biggest issue with all people have asked is, hey, they kind of jump straight into it, and you know, tends to bite them in the ass later when you're actually looking back and be like, damn, if I just stick it in like 2-3 minutes here, it would save me a lot of time doing the line. Cool. So we're gonna have two for loops, an inner and an outer. The outer one will go through each index, and then the inner one will go through each index starting from one to the right. And that way we can get every single different combination of numbers. Right. So we'll do like for integer I equals 0, right? And then we're basically gonna go all the way to while I is less than the length of nums. Length of nums, right? And then we have another loop on the inside. So we're gonna do integer j, and we're gonna have that equal to I plus 1 because we want to start 1 to the right of it. And then from there, same thing, j less than nums the length. Essentially what it's gonna do is create a 2D grid, and you're basically doing every single different combination you possibly can to go ahead and find the answer. So let me just go ahead and set that up real quick. Cool. So we look at this grid right here. It's essentially what we're doing. we're starting with 1, and then we're going like, okay, is 1, start at 1, the inner loop will be 2, right? So go 1 and 2, 1 and 3, 1 and 4. That doesn't work, we go down, we'll go 2, and then 2, 3, 2 and 3, 2 and 4. Doesn't work, we go down again. So we go 3, 3 and 4, and at this point, this will probably be the solution. That's what we're doing. We're creating a 2D array, and we're kind of just going through it. As we go through the matrix, we'll be able to find the solution we want, because you see we're doing an exhaustive search of every single combination we possibly have. It's not the prettiest thing, but it'll work. So let's go and try it. Yeah, wait, sorry, one last thing we do. And then all we're gonna do here is check if I plus j equals the result. Cool. And if it does, we go ahead and return it. And then if not, we go ahead and keep going. Cool. Yeah, let's do it. So 4 integer. Cool. So this is all the code we're gonna need. Let me walk through it. So for integer I equals 0, let's send the length of the array plus 1. Right. Pretty standard. Here's the second loop for the inner. Right. Remember, this is gonna be this half right here. So the first for loop is going through the 1, 2, 3, 4 up here, and then all these go to the subsequent. So the 2, 3, 4 in this first case, and then we'll cut down. So in the first iteration, it's 1, 2, 3, 4, and then for the inner for loop during the one case, it's going to be 2, 3, 4. Right. And all we're going to do is check if the values at these cells are to target, and if they do, we return the array with the indexes, right? Because we don't want the actual values, we want the index of the values. So that's why we have return new integer array ij. So let me copy that and let's paste that in LeetCode and see the result. Cool. Now we're in LeetCode. Cool. This should run. Let's do it. This should give us a solution. And wrong case where 0 expected 1 1. Why is this? Oh wait, yep, my mistake. I see it. And I do this actually every single time. Yep, this was I plus 1. Yep. That's why I don't like writing these like super vague, like one letter variable names, but you know, for time's sake, it's fine right now. It's a long day, but yeah, future you shouldn't really use single letter ones, and probably never will. Well, this kind of only really works because we know for sure that there's an answer. I mean, technically, if we didn't know, we could still do it, but you know, it makes a lot more sense because we know for sure there's an answer. But if we know that the value of 2 cells add up to the target that we want, we can actually write this a different way. We can actually write it as numbers A. It's going to be equal to target minus nums B. Now, why is this? Why does it matter? Why does this little change matter? Because if we think about it, every single number has a coinciding pair, right? It has a pair that'll add up to the target. And the way we find that is we subtract it from the actual target we want. Now, if we copy the array from up here, there we go. So we copy this, right? Let's say the target is 5, right? Let's say the target equals 5. That means we want to have 2 cells that are up to 5. What we could do is we want to see every corresponding, right? So make it more apparent. Let's say we start with 1, right? 5 minus 1 is going to give us 4. That means that if 4 exists in the array, that's the pair that we need, right? We don't know it exists because we're going to go through it, but we know that if we do see it, that's the answer we need. Now we go to 2. 5 minus 2 equals 3. So here we know that the corresponding pair for 2 is 3, and if we have it, we're good. 5 minus 3 is 2. Oh, look, there it is. So we have it, and then 5 minus 4 equals 1, which we already have. Now they have multiple solutions. I guess I could put it to 6, and that would have been 4 and 2. But the point stands is we're going to go ahead and subtract the number we have from the target and then see if we've already seen the corresponding number. The only reason it's a little bit more difficult is because we're using a data structure called a map based off of a hash. All we're really going to do is have a map, and it's basically saying, hey, if we see a number, we are going to add to the map if we don't have the corresponding number. Why? Because at this point, we don't have 4, right? So we're going to add 1 to the list. And then at this point, we don't have 3. So we're gonna add 2 to the list. And then right here, when we do 5 minus 3, we have 2 in the list. So we're gonna be able to pop out 2 and get the cell we want. And then we'll return the 2 indexes. A little confusing, but as I code it out, it should be a little bit more simple to understand. So for this one, what we want to do is we want to have a map, and it should be integer, and we'll call this scene values, right? Because the values we see has to be to a new hash map. Cool. And then all we're gonna do is for integer iterator equals 0, right? We're starting at 0. Iterator is less than nums.length. Here it's just different naming convention. I could also use I, but since I messed up with the other one, I'm gonna keep it as iterator. We'll show for iterator. It's fine. And we're gonna do plus iterator. Cool. Remember, this is just a variable name. It doesn't matter. I just tend to use iterator a lot instead of I. Right. So as we're gonna go through it, we have a question to make. Right. For each value, we want to know if we have the corresponding value. So we're going to create a new integer, and we're going to do wanted pair, right? Because this is the value we want. And we're going to set that value to target minus nums at position at the iterator position, right? So the first time we run this code, we run this loop, this will be 5 being the target minus 1, because that's the first value at 0. Right, because we're starting at 0. That'll be 4. And then what we're going to do is we're going to check if 4 exists. So if, let's see, where is it? Scene values that contains key, right? We're going to see if the value we want exists. If it contains 4. This will basically just check if it contains 4. Oh wait, sorry, not 4. Wanted pair. Yeah. Wanted pair. Contains wanted pair. There we go. Cool. If scene values contains key of the one. So we're gonna do if scene values contains key wanted pair. Basically, does our map have the value 4, right? In the first loop, we're gonna do the following. We're gonna return a new array. So return new integer array, and we need other values, right? These are gonna be indexes. So we know that the first index is going to be the iterator, right? And then the second value is going to be the value that we tied to 4. Because the map is 2 pairs. Basically a paired list. This is an easier way to think about it. A paired list, right? Where one integer is mapped to one integer. And basically here what we're going to do is we want to get the value, right? 4. Because the way we're going to add these in later is we're going to go ahead and add them in as the value and then the index, because that way when we call 4, we're going to go ahead and return the position that gives us 4. Return position. Cool. So here what we're going to want to do is we're going to get the scene values, and we're going to get with the wanted pair, right? Because in our case it's 4, so when we call get 4, it's going to return the position of 4, which in our case is going to be 3. Cool. And then let's see, that should do it. But this only accounts if we have the pair inside the map itself. But what if we don't see this? We need to actually add the value itself. So we're going to do an else, and we're going to do scene values dot add dot put. Cool. Remember, 2 values. First one being the value itself. So we do nums of iterator. And then the second value is going to be the iterator value itself, because that's the position. And let's see, that should do it. And then this code here should do it. So let's just walk through it. Now let's do, is that 4? Let's do 4. Let's say target's 4. Right, so we're gonna go from 1, 2, 3, 4. And now wanted pair. Remember, iterate 0 at the first count. So we're going to do 4 minus the value at 0, which is 1. So 3. Do we have a 3? No. First time we put no. So that means we put it in the map. Put in map. We want the value. which in our case is 1. Our position was 0. All right, so we're on loop number 2. And for number 2, once again, 4 minus 2 is 2. We don't have 2 inside our map. So once again, we're gonna go ahead and add it. So put the value 2 and then the iterator, which in our case is 1 at this point. All right, next one. We have 3. So 4 minus 3 equals 1. Do we have 1 in our map? Yes, we do. It's one of the first one we put. So for 3, it's yes. So that means we return the new integer array. And for these values, right, the first one's gonna be the iterator, which should be 0, 1, 2. And the next one is going to be the scene value, get the pair. So we want 1, right? Because 4 minus 3 is 1. We want 1. So in the map, we're gonna go ahead and get it. We're passing in 1. So in our map, 1 is keyed to the value of 0. So we get 0. So it's gonna return 2 and 0. So if we actually check that, see, add value, at index 2, right? 0, 1, 2. Right, so that's 3 plus the value at index 0, which is just 1. So 3 plus 1 is 4. And this is the answer we're expecting. So this should all work. We just go to put that in LeetCode and we should be done. Okay, putting it in LeetCode and submit. Now this should work and we should be all set. Cool. And look at that. This only takes us 2 milliseconds, which is a lot better than the previous one of like 44. So pretty straightforward. So not the worst problems. One of the first problems I was studying when I first started doing LeetCode problems a few years ago. It's nice. It's a nice refresher, especially in a language I haven't really used that much. I originally learned C++, then Python, now Java. Doing all these again in Java just to get a little bit more comfortable with it. But cool. 2 milliseconds. It's nice. I kind of want to be here at 0, but I'm not sure at the moment which is the best way to do that. And I think it's a little bit too advanced. But yeah, any questions, go ahead and down below. If there's any specific question you want to see, go ahead and drop it down below. And yeah, cool. See you next time.